Okay, this part's going to cover probably sections 2.4 through 2.5 of the geometry book, and I'm going to talk a little bit about mathematical modeling, which you use when you have a more complicated idea. Then, like before when we had the 7, 11, 15 type pattern where it just increases by 4 every time, it's a pretty simple pattern to figure out, so you don't really need much of a model. But if you have a question like for each, alright, so you have a group of people and every person gives everyone else in the group a handshake, how many handshakes take place? That sort of a question. It's a lot easier to create a mathematical model. So firstly you would say, well, if there's one person, there's no handshakes taking place. If there's 2 people, there'd be 1 handshake. If you have 3 people, 1, 2, 3 handshakes. 4, 1, 2, 3, 4, 5, 6. We have 5 people, 1, 2, 3, 4, 5. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 handshakes taking place. Right? It continues on that way forever, but if we want to know how many handshakes there are if there's 20 people, we don't want to draw a figure because that's really confusing when you have 20 dots and you have to connect them all. So the easiest thing would be to use the mathematical model to create a formula. And so we're going to look at it and say, okay, here it increases 1, it increases 2, it increases 3, and 4. I'm like, well, that's not like anything we've seen in the arithmetic sequences because it's obviously not linear. But this is actually a geometric sequence. And another way to look at it is if we have this, you can look at it this way. The first one, and for the second one, the third one. So you notice here, 0 over 2 is 0, 2 over 2 is 1, 6 over 2 is 3, 12 over 2 is 6, and 5 over 4, 20 over 2 is 10. If you're wondering where I'm getting these numbers, I'm taking a pretty typical geometric sequence notation. Like that. Let's take the n, so the number of people there are, times n minus 1 over 2, it'll tell you. So if I wanted to figure out how many handshakes take place if there's 20 people, I do 20 times 19 over 2 and get 190. Alright? Also another way to think of that is triangular numbers, because the number sequence we had there was, what was it, 1, 3, 6, 10, I think. If you think of it like this, you have 1 dot for the first row, and then you have 2 dots for the second row, and the next row you have 3 and 4. So the first row you only have 1, the second row there's 3 total, and then there's 6 total, and there's 10 total. That's called triangular numbers. They're exactly half of rectangular numbers, which you use for some other things, which would look almost identical except you fill in all the spaces. Those would be rectangular numbers. Alright, and now we're going to come across our first conjectures. We have the linear pair conjecture. We've already dealt with this when we were talking about angles. The linear pair conjecture states that if 2 angles form a linear pair, their sum is 180 degrees. It's pretty easy to prove this one, because if I had angle A and angle B, we know that this is a straight line here. Oops. No, that's a straight line. And we know a straight line always has 180 degrees. If you divide 180 degrees into 2 parts, obviously the sum of those parts is going to equal the whole. It only makes sense. But since we know this, we can prove the vertical angle conjecture, which we've already talked about earlier. These conjectures are really important because they're necessary for proving other things in proofs. You can use these to base other proofs off of. But the vertical angle conjecture states if two angles are vertical angles, then they are congruent. And actually, we can prove this one using the linear pair conjecture that we just had. So we're going to have the two intersecting lines, like we have in both cases. And I'm going to call this angle A, angle B, and angle C. Because of the linear pair conjecture, we know that angle A plus angle B equals 180 degrees. Right? We also know that angle B plus angle C equals 180 degrees. Of those two. Alright, so now we're going to solve for B in this top equation here and get that angle B equals 180 degrees minus angle A. So I'm going to substitute that into this second equation, so it ends up being 180 degrees minus angle A plus angle C equals 180 degrees. Subtract 180 from both sides and add angle A to both sides, and then you end up with angle C equals angle A. Angle C, angle A are opposite sides, vertical angles, they're congruent. That's all I really have to talk about right now. So that covers it through section 2.5.